Okay, so as mentioned before, your parent function, Ben V, what's your parent function? Actually, there's only one Ben now. The other Ben's in my fourth period, so I'm just going to call you Ben. Ben, what's your parent function? Very good. Okay, oh, that's too fat. Y equals x, very good. Parent function class is when you strip of all of the transformations, okay? And then the degree of this, Sophia Hun, what's the degree of f of x? Very good, okay. Now, this one has a name, okay? So, Burkay, what's the name of this function, Hun?
Linear.
Very good, okay. Linear because it has a degree of 1. Then it said, hey, you know what? Graph f of x using at least 5 points. I just need you to give me the inputs and outputs. You can graph this however you want. So, there's your 5 minutes. Paige, how did you graph this? What did you do?
For x, I put in -2, -1, 0.
Okay, so -2, -1, 0, 1, and 2, you said? And then what are the outputs, Paige?
-2, -4, 0, 1.
Really? Inputs and output is exactly the same? So -2, when x is -2, is that right, guys? Let's see. When x is -2, so -2 times -2 plus 4, what is that? Wouldn't that be 8? Okay. So I'm going to erase that. That will give me 8. Okay. Now, how about -1? -2 times x is -1 plus 4. What would this give me? Right? Because a negative times a negative is positive. Yay? Nay? Okay, so that's 6. How about when x is 0? That should give you an output of what? 4. How about when x is positive 1? 2. And then when x is positive 2? 0. So those are your inputs and outputs. If you were to graph it using inputs and output, there should be the same line as. Raise your hand if you didn't use your inputs and outputs for graphing. What did you use?
I just looked at it.
Tell me verbally, what did you use?
Well, I knew that the y-intercept was 4, and then I just did -2 over 1 as the slope every single time.
Okay, so y-intercept is positive 4, so go up 4. Is that okay?
Mm-hmm.
And then down 2, right, okay, down 2. You can go up 2 over 1. Okay. Now, guys, this should be the same as your input and output chart. Would you guys agree with that? Okay. So -2 comma 8 is exactly what I have up there. -1 comma 6 is exactly what I have. So make sure. All right. Perfect. All right, arrows and arrows. Okay. All right, let's try 2. Here we go. Let's put 2 minutes on the clock. I mean, 5 minutes, I should say. I'll pause the recording. So, Anders, what's the parent function for this one, hon? Beautiful. Okay. And then the degree of this. So, Jack, what's the degree of this function?
2.
Okay. So, x squared is 2. So, the name of this one. So, Alden, can you give me the name of this function?
Quadratic.
Very good. All the second degree is called quadratic. Okay. And then here we go. What I'm going to start with, class, is the parent function. Okay, so y equals x squared. Here's input, here's output. And remember, we did this quite a bit. Okay, so Shaughnessy, can you give me the 5 inputs and outputs for y equals x squared? Good. And then for the parent function only, what are the outputs?
4, 1, 0.
Perfect. Okay, so that's just the parent function. Now, you don't have just the parent function. You have a bunch of transformations. So guys, what's your a value for f of x? -2, right? What's your h value? -1. Very good. Okay. What's your k value? 4. Okay. The a is -2. You have 2 transformations right there. You have a reflection over x-axis, and you have a vertical stretch by 2. So that -2 is gonna change what? Inputs, outputs. Which one? X or Y's?
Outputs.
Outputs. So that's gonna be -2 times Y. Then you have a -1. What kind of transformation is that?
Horizontal shift to the left.
Right, it's a -1, so it goes left. What are we changing? Inputs or outputs? Okay, so inputs, that's x minus 1. Then you have a k of positive 4. What are you changing? Inputs or outputs? Outputs. Plus or minus? Plus, because that goes up. Okay, whoops. So this is now a positive. So now we're just going to change all the 5 things from the parents. So negative 2 minus 1 is now what? Negative 3. Keep on going. Negative 2. Negative 1. 0. And 1. Okay. 4 times negative 2 is negative 8. And then negative 8 plus 4. Whoa, don't do that. Yeah. Let me lock it real quick. Okay, so that's 4. Negative 4?
Yeah.
Okay. Negative 2 times 1 is negative 2. Negative 2 plus 4 is? 2. 0 times negative 2 is 0 plus 4 is? 4. 1 times negative 2 is negative 2 plus 4 is back at? 2. And then how about when 4? 4 times negative 2 plus 4. That will give me what? Negative 4. Okay, so these guys are your points that you can use for plotting. So negative 3, negative 4, if I can count. Negative 2 is positive 2. Then negative 1 all the way to 4. 0 is back at 2. Then 1 is now back at negative 4. Okay, so make sure it looks like a U and not a V. Okay. All right, last one, another 5 minutes. So why don't we try that one? Yep, printed note, just change it A, B, C, D since I messed up on that one. Kimmy, what's your parent function for this one, hon? Oh, no, the parent function, letter A. What is the parent function? Beautiful, okay. Okay, what is the degree of f of x? Beautiful. C. Okay. C, Joe, what is the name of this function? Beautiful. Okay. Then I'm going to start with the inputs and output for the parent because it's easier for me to get it from there. Nicole, can you give me the 5 inputs and output, please, for the parent?
Negative 2, negative 1, 0, 1, 2.
Beautiful. And then outputs?
Negative 8, negative 1, 0, 1.
Perfect. Okay. So now we're going to list out the A. What's the A value, Griffin, for this function?
2.
Perfect. Okay. H value, can you handle this? Ainsley. No, she's my 4. Okay. Nico, no, absent. Aaron, can you give me the H value, please?
3.
Perfect. Then we need the Katrina. Can you give me the K value, please? Perfect. Okay, so the A value, what are we going to change? Hannah, inputs, output. Perfect. So that's going to be 2 times Y. H is 3. What kind of transformation? Ashley, what kind of transformation is that? It's positive. Huh? Go ahead, consult your team. To the? Very good. So are we going to add to the input or the output? Input. Okay, remember right and left are x's. Okay, so that's going to be x plus 3. Then you got k equals 1. Caitlin? K equals 1. What kind of transformation is that? Transformation. Up, down, left, right. Which one?
Up.
Up. Good. So now what are you going to add it to the y or the x? Perfect. So add 1. Beautiful. All right, guys, let's transform. Here we go. Take all the x's, add 3. Ben, take all the x's, add 3. Give me all the 5 new outputs. Negative 2 plus 3 is now what, Ben? Good. Negative 1 plus 3. Negative 1. So all the parents, we're going to take all of it and we're going to add 3. Uh-huh. 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 Beautiful. All right. Now take all the outputs, okay? Joey, take all the outputs.
Negative 15, negative 1, 1, 3, 17.
1, 3, and 17, you said?
Yeah.
Someone confirm that for me? Perfect. And I just have to plot. I don't have 15 or 17, so I'll skip those. But I have enough to make a lazy S, right? 2 is now negative 1. 3 is positive 1. 4 is 3. Okay, if I need to, I can probably extend that to like negative 15 down here. And then if I want to, negative like that. But you can always go above and beyond the grid. Or you can always rescale it. Perfect. All right, there you go. Okay, so new students, that's what we study first semester, right guys? That sums up all the functions. Okay, we do have new functions, so go ahead and one person go grab the Chromebook for the desk, the person that can get out the easiest. Look at your team's number, okay? And then the rest of you, if you guys don't have printed notes, go ahead and copy that down and wait for your Chromebook to come back. Once you have your Chromebook, go ahead and get to Desmos. Yeah.
Good. Hey Joe. Hey Joe.
Yeah, Joe. Okay. All right, here we go. This is, let's fill this in. This is a linear, okay, with x-intercept. Someone remind me, number one, what was the x-intercept at? Negative 2, comma 0. And then we graph g of x out in your Desmo. Raise your hand if you can tell me how are those two related to one another. What do you guys write? Volunteers or draw out names? So, answering. How are f of x and g of x similar, different, related?
I wrote they were both represent y.
Well, only f of x and g of x. How are the functions? Okay, when you see f of x and g of x, that means they're functions. Okay, when you graphed it out, what were some similarities, some differences, relationship?
Oh, that one's the reciprocal of the first one.
Okay, so which one is the reciprocal? G of x? Yeah. G of x is the reciprocal of f of x. What else? If you graphed it out, what do they have in common? What were the differences between the two of them besides? Going once?
G of x one's curved and the f of x one is straight.
Ah, okay. F of x is straight. And g of x has how many curves?
One on each line.
G of x has how many? Two curves. Okay, so let's call it 2 branches or curves. What else? What's happening at the x-intercept? Yeah, okay. So at the x-intercept of f of x, that was the first one, g of x can't have that value. Okay. So those are all the relationship between a line and its reciprocal. Then number 2, similarly, okay. I'm sorry, not 2, 3 and 4, h of x is a line. And from Aline's, we knew that there was an x-intercept at where? 3, 0, okay. And very similar to the answer of number 2, how are those two related? Definitely L of x can't have an x value at where? At where? How? X equals what? At x equals to 3, wherever the x-intercept was, right? And then everything else should be the the same as the first one. Okay. Okay. All right. Any questions so far? Anybody, do we all know where to get your notes for the night? What I'm going to do is I'm going to ask you guys to plug your Chromebook back in neatly, and then go ahead and start on your